Hello everyone, welcome to Codeforces Round 974, which was a Division 3 contest. And yeah, I'm here in Bergen right now. So I have started my PhD and I hopefully will continue keep giving Codeforces contests regularly. So yeah, let's dive into the questions now. So the first question is Robin helps. In this question, for every test cases, we are given two integers n and k, and the next line contains n spaced integers. Okay, and what we essentially have to do is uh, count the number of so what this numbers signify is the amount of wealth with n people, amount of gold coins with n people, a1 up to a. And what we have to do over here is, so what happens is Robin checks if a particular person has greater than equal to k gold. If it does, then Robin takes away the gold. If someone has zero gold, then uh, Robin gives the one gold to them. So we essentially have to count the number of people Robin gives gold to. So it's a very straightforward question. You just have to follow what is asked in the question blindly. So you just have to implement what is asked in the question straight up. So moving on to the next question, Robin Hood and Major Oak. So in this question, the tree major oak grows I raised to I leaves every year. Okay, and each leaves stay on the tree for k days, k many years. So what we have to determine is we are in this question we are given the integers n and k, and we have to determine that at the end of nth year, we have to determine that in the nth year, do we have even number of we have to determine whether do we have even number of leaves on the tree. So first observation is I raised to I is equal to odd. I raised to I will be odd if I is odd, else I raised to I will be even. Okay, and the second observation is so since the tree so leaves stay on the tree for k many years, so at the end of the nth year only trees from n minus k plus 1 to n only leaves which grew in this year will matter. Okay, so we just have to check whether how many trees grew in this year. So that is essentially asking how many odd numbers, what is the parity of number of odd numbers from n minus k plus 1 to n. So this is very simple. We'll find so essentially we will find the distance, find the difference between this, and that is essentially k, and we'll check whether we just have to check whether in this interval how many times odd number comes up. So checking the so in order to do that we can essentially take the difference between them, and now if whatever the difference modulo 4 is 0 or 3, then we have even number of leaves. If the even number of leaves, else we have odd number of leaves. And I guess that is pretty much clear. Nothing more to explain over here. Moving on to the next question. which is Robin Hood in Town. In this question, we are again given an integer n, and the next line contains n integers a1 up to an. And what does this integer signify? So this integers essentially signify wealth of n people. So what happens in this question is the richest person, essentially whose wealth is maximum over AIs, gets a pot of gold with X gold coins. So essentially his wealth becomes max of wealth becomes max of AI plus X. Now, since now we say that a person is unhappy or okay, not unsad. A person is sad or dissatisfied or whatever we call it if his wealth, so if the person's wealth is strictly less than half of the average. Okay, so if we rearrange this equation, we get if this is the case, if this is happens, then the ith person is dissatisfied. And when strictly half of the people, strictly half of the total people are dissatisfied, then Robin Hood occurs. So we have to determine the minimum amount X required so that Robin Hood shows up. So in order to solve this question, we'll make few observations. First is when n equals to 1 or n equals to 2. If n equals to 1, then there will be only one person, and he will always his wealth will always be greater than half of the total wealth, because he is the only person here. And when there are two people, so if somewhere we have wealth disparity like 1 and 100, no matter how much the bigger person, no matter how much the richer person get, it won't happen ever that both of them are dissatisfied, like strictly greater than half of the people are dissatisfied. So when n equals to 1 or 2, we can just print -1, saying that does not exist any amount by which people would be sad. But when n becomes greater than equal to 3, so I'll take an example. For example, n equals to 5, and we have 1, 2, 3, 4, 5 as our people's wealth. So now you can see that this array is in sorted order, and when we can say when n by 2th person, ceiling of n by 2th person gets dissatisfied, if that person gets dissatisfied, which means the entire everyone behind him got dissatisfied, and then we can claim that if this person in the sorted order of the wealth, in the ascending order of the wealth, if the n by 2th person gets dissatisfied, then we can say that in this situation we can say that essentially that Robin Hood will show up. So in order to solve this question, what we'll do, we'll first sort the array. So we'll first sort the given array, and then we'll apply the dissatisfaction condition on this guy. So array of n by 2, 2 into n into array of n by 2, that is what we saw earlier, is less than sum of ai plus x. So this is the condition. Therefore x should be greater than 2 into n into a of n by 2 minus sum of ai. So we just had to find the smallest x, like the smallest x satisfying this condition. So if x turns out to be negative, like this quantity turns out to be negative, then in that situation we can just print 0, that which means that people are already sad about everything. But if not, then we will just, our answer will essentially become 2 into n into a of n by 2 minus sum of ai plus 1 and max of this quantity. So yeah, that's the third question. Moving on to the next question. Robert Hood and Mrs. Hood. So in this question, Robin's brother and mother are showing up at his house, and we have days numbered from 1 to n. We have days numbered from 1 to n, and Robin decides to take up k risky jobs. Robin decides to take k risky jobs such that Robin decides to take k risky jobs, and Robin's brother and mother have to visit his house, but we have to and when they visit, they are going to stay for d days, both of them. So we have n days, k risky jobs, and d days of stay. So we have to plan the visit of Robin's brother and mother such that there is maximum overlap. There is maximum overlap between the brothers are maximum number of the brother overlaps with the maximum number of jobs, and mother overlaps with minimum number of jobs. So in order to do so, what we'll do? So let us take an example. That is a example test case, that is 9 to 4. Okay, and so in this case we have the intervals 7 to 9, 4 to 8, 1 to 3, and 2 to 3. So one of the most important thing to observe in this question is that the constraints that days are of the order 10 to 5. So which means so how we'll approach the question is, we'll first create an array of size n plus 2 and initialize it with 0. So so in this case we'll make an array of size 11. So final index will be 10. Okay, and now let us try to look at each of the job. So say 7 to 9. So this job will last from day 7 to day 9, but if you visit on say 6, even then you will encounter this job, right? So what we can do is, so essentially what we can do is what I intend to do is, when we get input of the intervals of the job, we replace L by L minus D plus 1, essentially max of this two quantity. So if the interval is in the beginning and the D is too large, so instead of that we consider D as 0, or rather make it as 1. Okay, so we replace L by this quantity and R as it is. And what we do for every interval, we replace L is equal to this, and and in this array that we have constructed earlier, we for every interval, for every L of interval, we increase the quantity at L by 1. So in this case 7 will become 6, so we'll increase 6 by 1, and at R plus 1 will decrease by 1. So we'll have minus 1 over here. Similarly for 4 to 8 will be converted to 3. 4 to 8 will be converted to 3 to 8. So we'll get plus 1 at 3 and we'll get minus 1 at 9. Okay. So then next we have 1 to 3. 1 to 3 will, from 1 to 3 we'll get plus 1 at 1 and minus 1 at 4. And for 2 to 3 we will again have we'll have 2 at 1 and minus 2 at 4. Okay, so now once we have this array, what is so special about this array? Now let us take, now all the remaining places will be 0, and now take the prefix sum of this array. So we will have 0, 2, 2, 3, okay, so we'll have 0, 2, 2, 3, then 1, 1, 2, 0, sorry, 2, 2, 1 and 0. This will be array. What is the speciality of this array? By prefix sum, I mean prefix sum of I. Prefix sum of I is essentially sum of all elements from 0 to I. So a prefix sum is essentially sum of all the previous numbers. So like for this, for the index 3, this is basically sum of 2 and 1. Okay, sum of all the previous numbers. Okay, so now what is so special about this array? So this array essentially tells us that if I arrive at date I is equal to at certain I, at some day I, it tells us how many jobs I will overlap in that situation. So essentially in this array, we'll have to report the index of max and min. The only thing we need to take care of that we need to check the max and min in the duration 1 to n minus d plus 1 in this duration. In this duration, we have to report max and min of the array. Okay. So this was question number 4. And moving on to question number 5, the problem E, which is called rendezvous of Marianne and Robin. And okay, so in this question we have two people, Robin and Marianne. They are at vertices 1 and n respectively. So in this question we are given an undirected weighted graph. In this question we are given an undirected weighted graph, and what we have to do is essentially so our graph looks like graph looks something like this, and on every vertices we might or might not have an horse. Okay, we may or may not have a horse on every vertex. And second thing is, so what we have to find, and the edges will have weights, and this signifies that the travel time required to go from edge U to edge V. The weight signifies that. And if you are carrying a horse, if you are riding a horse, then the weight is like the time taken to cross the edge is halved. So what we have to determine in this question is for to find the minimum time required for Robin and Marian to meet at a particular vertex. Okay, so in order to solve this, what are we going to do? We are going to use Dijkstra's algorithm. So suppose if there were no horses at all. So in this situation, what we could have done? We could have applied Dijkstra's algorithm by considering 1 as the source. We would have applied Dijkstra's algorithm using n as the source. And then for every vertex starting from 1 to n, we would have calculated the following value: min over all i's from 1 to n, and max of distance of Robin at I and distance of Marianne at I. Okay, we would have calculated this. We would have calculated this distance. So but now we have horses on some vertices, and that will decrease the speed. So in order to handle this case, what we are going to do is, uh, in order to handle this case, a better approach will be, so in our Dijkstra's algorithm, Dijkstra's algorithm, what we essentially do is, we have order sorry, in the Dijkstra's algorithm, we have a distance array, which essentially stores the distance of a particular vertex from the source node. Instead of maintaining one distance array, we'll maintain two distance arrays, and one will called with horse and other will called without horse. Okay, so essentially what this means is, uh, this two arrays signify that whether can what is the minimum distance to be at vertex I with horse and without horse, with horse and without horse. And you just need to so when we update the when we relax the vertices in the Dijkstra's algorithm, when we relax the distances, we essentially need to take care of the fact whether we are already at a uh, uh, carrying a horse or not. So essentially, when we use priority queue or set or priority queue for the implementation, we need to take into account that in the standard implementation, we just care about the node and the distance in the priority queue is a pair of node and distance. At this instead, now what we are going to maintain a node, a distance, and a boolean which tells whether we have horse or not. Horse or not. Horse or not. Okay, so we have to find these. We have to find this. Uh, Instead of this data a tuple, we have to maintain this tuple. Okay, and everything will be same. We just have to be smart about when to update this horse, when we are going to update this horse there or not there boolean, based on whether we encountered a horse or not. Okay, so that is all we need to do in this question. Thank you.